video, we are going to discuss about the project title Person Vein Identification using CNN. Finger vein identification is recently developed biometric technology and has become an essential field in biometrics, garnering increasing attention in recent years. As a biometric track using vein pattern allows for person recognition with high security. Biometrics has quickly distinguished itself as being the most accurate, credible, and fast form of authenticating persons' identities. Based upon the biological characteristics, biometrics has allowed for more convenient identifications than convenient identification cards or passwords. Several biometric signatures such as face, fingerprint and hand geometric and iris has been used for controlling access and using authentication in security systems. In traditional biometrics, these signatures can be altered or falsified as they are on the superficial to the human body. The main objective of this project is to using convolution neural network to identify person based on finger vein. Hardware requirements: we need operating system Windows, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Coming to the software requirements, we need to install Python with the version of 3.7. Methodologies. To implement this project, we have designed few modules. First one, upload finger vein dataset. Using this module, we will upload dataset to application and then find and plot different person finger found in the dataset. Next module, pre-processing dataset. Using this module, we will read image and then resize all images to equal size and then shuffle and normalize image and then split the dataset into training and testing, where the application used 80% of images for training and 20% of images for testing. The next module, run support vector machine algorithm. 80% of pre-processed trained images will be input to support vector machine to train a model, and then 20% of test images will be applied on trained model to calculate the prediction accuracy. Fourth module, run CNN algorithm. 80% of processed trained model images will be input to CNN model to train a model, and then 20% of test images will be applied on the trained images model to calculate prediction accuracy. Fifth module, comparison graph. Using this module, we will plot comparison graph between both algorithms. Sixth module, identify finger vein from the test images. Using this module, we will upload test finger vein image and then CNN will analyze vein image and then identify person from that image. Next, coming to the execution, close this file and go to the code file. This is the code file, consists of dataset file which contains dataset images of different persons. Then this is the images which are used for training the output, and this is the model file, consists of pickle file and .hy file and .npy file formats. Coming to the pickle file format is a serialized data format in Python used for object serialization. It allows you to save Python objects into a file and later load them back into the memory. Coming to the .hy files, which contains deep learning algorithm informations, and .hy file can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Then coming to the .npy format. It is the standard binary file format in NumPy for persisting a single arbitrary NumPy array on the disk. The format stores all of the shape and data types information necessary to reconstruct the array correctly even on another machine with a different architecture. The next one, these are the text files used to test the algorithm CNN, and this is the main code file, and this is runbad file. This runbad file, instead of executing the program in command line interface, we created Windows bat file to execute the project. Now by clicking double tap on it, it leads to the graphical user interface which is executing and leads into the program which is helpful to the user. Now click on the first button, upload figure vein dataset. By clicking this button you can select the dataset and click on the select folder. Now you can see the different types of persons finger vein dataset which was indicated in the x-axis ID and y-axis the image count. Close this graphical representation and you can see the dataset is loaded. Now click on the pre-processing dataset. By clicking this button you can see the dataset was written into the test data and train data with the sample records, and this is the sample of normalized dataset. Now close this file and go to run support vector machine algorithm. By clicking this button you can see the algorithm confusion metrics and each person's, and also close this graphical representation. You can see the accuracy score of support vector machine algorithm. Now run CNN model algorithm. By clicking this button you can see the confusion metrics of CNN algorithm, and you can see the predicted class and true class of different persons, and close this file and you can see the accuracy which was predicted with the CNN algorithm. Then click on the comparison graph. By clicking this button you can see the graphical representation of algorithm's accuracy, precision, recall and F1 score. In the x-axis it is indicated the labels of the algorithms, and in y-axis it indicated the count of the algorithm's accuracy. Now close this one and click on the next button, identify finger vein from test image. By clicking this button you can upload any of the images to test it. So first image I have selected, it was indicated that this vein is related to the vein of a person 26, and upload the next image and test it. So I have uploaded the next image and it was indicated as vein of the 9th person. Now exit this file and go to conclusion. We have founded that in this project, by merging CNN algorithm is literally considered as architecture that useful for many neural networks, has founded that finger vein recognition databases are small and structured of veins are simple, which influence the training process. So by experimenting the results in this project and also the real world data demonstrated that CNN algorithm was predicted with the best accuracy in this project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.